The next problem that we're going to look at today is an emulation of a Turing machine 11.1, and it is telling us to, for each of the strings, show that the final tape and say whether the TM accepts it or not. So we're given four strings here to test with our Turing machine: 0011, 101010, 110, and 00100. So first we need to create this Turing machine. And it can be hard to see, but that is our given Turing machine that we're working with here. So we need to create this in code first before we can start running our strings against it. So the first thing we need to do is create our tape. So I simply use the list in Python to store everything. So I'm going to use x's as our deltas. I'm only going to be using a Turing machine with deltas on both sides. And it can go on forever in both sides, but for now I'm just keeping it as two x's on the both ends. So first thing I'm doing is appending an x, then I'm appending all the letters of the string given, and then we're appending an x on the end as well, so the two deltas on the end. So the first thing I need to take note of was the index I was on for the Turing machine. So if I have a strip for the Turing machine, I need to know where I'm pointing to. And the other one is what state I'm in. So for the given graph for the Turing machine, I need to know if I'm in state 1, 2, 3, or in the accept state. So what I simply do is I create an infinite loop that just keeps running and running and running and running forever. And the only way to end it is if I find that a pointer dies inside my graph, or if I land inside that accept string, that accept state. So in node 1, we can see that we have 1, we replace it with 1, and then we move right. We move a pointer right on the tape. And so the replacing with 1 doesn't necessarily need to be done on the list, because although the action is important in Turing machines, we don't need to physically rewrite the code to replace that 1. So it can just stay as a 1, and we can just move our index over to the right. If from that node is 0, then we replace that with a delta, and then we move to the right, as well as changing nodes and changing our state to state 2. So we can see from the start state that if we read in a 1, it stays a 1 and we move to the right. But if we read in a 0, we switch it to a delta, go to the right, and then move over to this new state here. So this is what we're kind of simulating here. Now the only thing that we don't have is in that first state, we don't have a delta in the actual graph. But because we can't actually determine if we'll fall into an infinite loop without actually crashing the computer, then we will have to take into account that if we read in an X, then we know it'll die because the pointer in that graph cannot actually go anywhere. Then we will move on to node 2. So this is very similar to the other one. If we get 1, we replace 1 and we move to the right. However, we stay in the same state. We read in a 0 from state 2, replace it with a delta, and we move to the left, but we go to state 3. Then, if we read in a delta, this is where we accept. So when we read in that delta, if we're on delta, then we stay on that delta and we accept. Then on that final third state, if we read in a 0 or a 1, we move to the left, we replace them with 0 to the 1 relative to the same number. And if we read in a delta, then we move to the right and we go back to state 1, and then we repeat the same process over and over again. Now we can run this and actually see what can see of A, B, C, and D, which of the strings this TM accepts. So if we look at this, we can see that problem A does not accept, and this is our current tape with pointer at the second position. Then we have from problem B, which it doesn't accept either. This is the current tape, the final tape, and where the pointer was last pointing at. We have problem C, which was 110, and this one was accepted. The pointer was at 4, and problem D, which was 00100, which was false. This was the final tape, and this was where the pointer was pointing.